The Naval Surface Warfare Center, Carderock Division, is the U.S. Navy's state-of-the-art research, engineering, modeling, and test center for ships and ship systems. Located in West Bethesda, Maryland, Carderock employs more than 1,500 civilian scientists, engineers, technicians, and support staff. The size and scope of this research campus is unique to the United States and the U.S. Navy. One part of this facility that's especially noteworthy is the Magnetic Fields Laboratory. This laboratory, run by Carderock's Underwater Electromagnetic Signatures and Technology Division, also known as Code 75, is at the forefront of naval innovation in the area of naval stealth technology. The Magnetic Fields Laboratory facility consists of 3 specially constructed buildings. In order to enable the researchers of Code 75 to conduct the most accurate, high-precision magnetic testing possible, all 3 of the Magnetic Fields Laboratory buildings are designed so they have almost no magnetic signatures. The materials of the building and equipment that are a permanent part of the buildings are as non-magnetic as possible. The buildings have wooden roofs and doors, plastic and aluminum heating systems. Even the concrete in the foundations was screened before it was poured to ensure it had sufficiently low magnetic content. These magnetically clean environments allow for accurate modeling and measurements without interference. The magnetic field intensity and direction, also known as a signature, can then be measured for a specific submarine or surface ship class. To accomplish the necessary measurements, each Code 75 building is designed to perform a specific function in the signature measuring and reduction processes. Building 83 is the smallest of the 3 buildings of the Magnetic Fields Laboratory and houses a triaxial magnetic field sensor used to track and record magnetic field strengths in the area surrounding the facility. This allows the scientists and engineers to subtract the local background fields during testing and measurement. In Building 82, a coil system surrounds most of the interior volume of the building. The system consists of 3 orthogonal coils operating on 3 axes measuring 40 feet long by 16 feet wide by 16 feet high. They are capable of producing the large magnetic fields required to reduce or remove the naturally occurring magnetic fields existing around any ferrous metal object, in this case, a ship or submarine model. Any item up to 24 feet long, 6 feet wide, and 6 feet high that weighs less than 44 tons can be put into Building 82 and subjected to the large external magnetic field that's generated by the coil system. This process is known as deperming. Deperming reduces and tunes the magnetic signature around the ship to a known level. The new field values are measured and the model is prepared for the next step in the signature reduction process, degaussing. While deperming can greatly reduce a ship's magnetic signature, a degaussing system must be installed in each ship to counteract the remaining magnetic field. Code 75 does much of their work on scale models rather than on life-sized ships and submarines. The models used are typically between 1/30th and 1/60th in scale and are built to be as magnetically faithful to the full-scale platform they're modeling. So the models are built out of the same material that the full-scale platform will be, typically steel. A scaled-down degaussing system is built into the models so the measurements will be fully consistent with their full-size cousins. After deperming of the model is complete and the degaussing systems installed, tests are repeated on the models to evaluate the predicted performance of the degaussing system. These tests are conducted in the largest of Code 75's facilities, Building 81. The primary use of Building 81 is to test the magnetic signatures of the physical scale models. It's divided into 2 sections, used to perform 2 types of signature measurements. The north end of the building contains a triaxial coil system measuring 40 by 40 by 40 feet. This 40-foot cube produces an exceptionally uniform magnetic field with variations of less than 1/10 of 1%. The system is used to replicate the magnetic field of any location on Earth. This allows the Code 75 team to determine, for instance, what the magnetic signature of a submarine would be in the Persian Gulf or in the Mediterranean. Nearly 300 triaxial magnetic field sensors are installed beneath the floor of the main level of Building 81. A laser surveying system was used to measure the precise position of each sensor. These underfloor sensors, along with custom-built sensor arrays, measure the magnetic signature of any item in the north end of the building. A water brake system allows engines and motors to be measured under an operating load during testing. The north end of Building 81 also has a heavy item test floor that can support up to 44 tons. The south end of Building 81 has its internal volume surrounded by a triaxial coil system, similar to the one installed in the north end. It's twice as long as the north end, measuring 80 by 40 by 40 feet. Both systems are used to control local magnetic fields to facilitate physical scale model measurements, with sensors measuring the magnetic signatures themselves. The most prominent feature of Building 81, South End, is a track and trolley system used when taking magnetic measurements of physical scale models. Models of up to 12 feet in length and weighing 1,000 pounds connect to this system. The model can move a distance of 35 feet at a selectable speed through the coil and sensor array. The measuring array consists of 10 reconfigurable rings where magnetic field sensors capture a near 360-degree picture of the magnetic field surrounding the ship model. Through these results, the Magnetic Field Laboratory validates signature performance crucial to the Navy's mission. At Carderock's Underwater Electromagnetic Signatures and Technology Division, we take great pride in our unique contribution to the protection and service we provide to our country and our Navy. The research and testing we do here keeps the U.S. Navy as the world's leader in developing and maintaining the best possible magnetic stealth technologies. By reducing the vulnerability of the Navy's vessels to mines, torpedoes, and other dangers while operating undetected, we improve the strength of our nation and the safety of the sailors who defend her interests.